Yep, it's another weekend and another session of work on this solar charge controller, but this thing's going to be good. If you think of all of the 12 volt PWM solar charge controllers you've ever seen, this is probably the best one, or will be when it's completed. It's got very good charge management, which is also all reconfigurable in the software. It's got really good current handling capacity. This thing just as built is going to handle 30-40 amps no problem, and you can just double up on the MOSFETs for as much as you want. All of the power switching MOSFETs are N-channel, so pretty much no losses. It has an active diode circuit in it, so no Schottky drop losses. 0 volt effective diode drop, very nice. There's not much more you can improve on this. It's just going to be such a good design, the way I envision it. But so far, all I have is a Arduino Pro Mini microcontroller, a screen to monitor the voltages, which is currently showing no load, no charging rod current, and no battery voltage because that's not hooked up yet. That's the current monitoring board, as seen in previous video. Maybe 10% accuracy, but that's 10% accuracy without needing any manganese alloy precision shunts or 1%, 0.1% tolerance resistors, and 10% accuracy is good enough. The main reason for this is the overcurrent shutdown alert, knowing when to turn the ideal diode on, and monitoring when to switch the battery from saturation to float charge, all of which 10% accuracy is quite enough. This bit I've been working on today, or part of today, is just a level shifter. Takes the 3.3 volts from the Arduino into a 12 volt drive for the output switching MOSFET up there. And this is to solve a, well, you actually have to have one of 3.3 volts to switch those things. It's to solve a problem with my earlier design, in that if you were to operate it with the panel connected but not the battery, it could go over the maximum gate voltage on the output stage and blow it. That is why there's a little Zener clamp diode in there, and if you watch the output as I increase the voltage, it just stops. Ignore the clicking, that's just to relay my power supply at about 12 volts. So no more blowing the gate. Once I get this done, this is going to be a really good controller. It's all going to be open hardware, and there's a couple of them you can find, Arduino based PWM solar charge controllers, but being quite honest, this will be the best one. The next part to work on, once I get that breadboard switch to a Stripboard, is the input switching, which includes the ideal diode. Most of that circuitry is concerned with level shifting, because it's going from 3.3 volts positive logic from the output line. Let's start again. The Arduino gives 3.3 volt output logic, which is referenced to the battery negative, which has to be converted into negative logic referenced to the battery positive, which has to be converted again into positive logic, this time 12 volts, so it can drive a power MOSFET, referenced to the solar panel negative. So there's a few transistors involved. But again, this is all that's because I insist on using N-channel MOSFETs for all the power switching. No P-channel. Lower R on, so higher current handling. This thing will handle 30-40 amps easily, even before you start doubling up on MOSFETs. And lower losses. And between that and the ideal diode circuit, this is probably the most efficient you're going to get without going the MPPT route. So I am very pleased with myself and pleased with my design, and I have a lot more work to do to get this thing completed. But when it's done, it will all be documented in great detail, and as this is designed to be either mass producible or hobbyist producible, it can all be done without any surface mount components. It's all doable using Stripboard through-hole parts. Doesn't have to be. It is still suitable for mass production if anyone wants to do it, but it's also a very hobbyist friendly system. I'm going to get back to work on the next section.